Alright, so this is our Honors Chemistry Section 3.4 lesson video. And so we are going to cover density, and unlike the Section 3 lesson video, this one should only be one part. So let's go ahead and knock it out. So density is just the ratio of the mass of an object to its volume. It kind of deals with how compact the particles are. So density equals mass over volume. And so when you look at these two, you can see they're taking up the same amount of volume, but these particles are packed a lot closer, so there's going to be more mass in the same amount of space. So this substance would be more dense because the particles are packed closer together, so you get more mass per volume. Density is an intensive property that depends only on the composition of the substance and not on the size of the sample. So for example, the density of water at room temperature is 1 gram per milliliter. So it doesn't matter if you have a little bit of water or a whole lot of water, because it's still water at the same temperature, it's going to have the same density. Because you have to think, as the volume of water increases, so does the mass. So it's still, the ratio is going to be 1. Alright, so because most substances change volume when they are heated or cooled, densities are temperature dependent. So that's why in the previous slide I just told you water at room temperature. The density of a substance generally decreases as its temperature increases. So if you look, here's an example. You can see that density decrease as temperature is increasing. However, water is an exception to this rule. That's why ice floats, because ice, the solid form of water, is actually less dense than the liquid form, even though it's colder. But most substances, the density decreases. So that's how hot air balloons, or like sky lanterns, work. Is you have air inside the lantern, you add heat through like a little flame, like on a candle or something, so the air inside the lantern increases in temperature and becomes less dense, so it will float. Whenever something is less dense, it floats. If something's more dense than another object, it will sink. So let's look at some of the math related to this. So remember, our formula is density equals mass over volume. So it says calculate the density of mercury, so we're looking for density. If 1 times 10 to the 2 grams, which is my mass, occupies a volume of 7.36 centimeters cubed. So there's my volume. My formula is density equals mass over volume, and since I'm solving for density, I can just plug in. So my mass is 1 times 10 to the 2 grams. My volume is 7.36 centimeters cubed. So I just divide my two numbers. So once I divide my two numbers, I get 13.59. And then my unit would be grams per centimeter cubed. Density will always have double units. Always have double units. It could be like grams per centimeters cubed, it could be grams per milliliter, it could be kilograms per meters cubed, but you'll always have double units. Alright, so this one says calculate the volume. So this time we're going to look for V of 65 grams, so there's my mass, of the liquid methanol, wood alcohol, if its density is 0.791 grams per milliliter. Okay, so this time I have my mass and my density, I'm looking for volume. So we need to rearrange our formula to solve for volume. Now, if you struggle with rearranging formulas, I don't cover this a lot in class because I expect that you already learned this in algebra. However, if you did not, that would be something you would need to see me outside of class for tutoring for. Alright, so we don't want to solve for something in the denominator, so the first thing I want to do is get it into the numerator. So I can do that by multiplying both sides by V. So now V times D equals M. I'm still trying to solve for V, so I do want it to be by itself. So I divide both sides by my density. So again, if what I just did was confusing to you, or the fact that I rearranged and got this instead of, what do you always put? You always put it backwards, D over M. If you can't figure out how to rearrange for this, that's when you would want to come to tutoring. Alright, so we plug in. So my mass is 65 grams, and my density is 0.791 grams per milliliter. So if you look, my grams are going to cancel. And so then once I divide in this case, I get 82.17, and the unit that I'm left with is milliliters, which makes sense since I'm solving for volume. Alright, so let's look at this last one together, and then I will let you try some. So it says, what is the mass in grams, so this time I'm looking for mass, of a cube of gold if the density is 19.32 grams per centimeter cubed. So there's my density. If the length of the cube is 2 centimeters. Okay, well, y'all, they told us it's a cube. That means all the sides are equal. So if we know the length of a cube, volume is length times width times height. So I'm just going to have to do that before I can plug in. So length times width times height. So it would, of course, be 2 times 2 times 2, which, of course, is 8. And then it's going to be centimeters cubed. So that is my volume. All right. So I have my volume. I have my density. This time I'm trying to solve for mass. So volume equals mass over density. So if I want to solve for mass, I move density to the other side by multiplying both sides by density. Whoops, sorry, I don't even know why I just wrote the formula like that. Density equals mass over volume. I don't know what I was doing. So if we're solving for mass, then I need to multiply and get volume to the other side. And it would be volume times density. I know that's what we just got, but for some reason I just wrote the formula as what we had just derived it as. All right, so mass equals volume times density. I didn't want to confuse you, but that might just happen. So then we just plug in. So the volume we calculated was 8 centimeters cubed. And then the density is 19.32 grams per centimeter cubed. Okay, so if you look, my centimeters cubed are actually going to cancel out. And I'm left with grams. And so then I just multiply my two numbers. So once I do that, I got 154.56 grams. And that's it. So the only tricky part about this one was making sure you remember volume is length times width times height. And knowing that a cube has the same length on all sides. That also would throw you off if you didn't remember that. All right, so let's erase and let me give you a chance to try some on your own. All right, so there's my answers. So you might want to pause the video and try some of these on your own, and then that way you can check your answers. So I'm going to assume you've done that. So the first one says calculate the density, so we're looking for D, of a 374.5 gram sample, so there's my mass, of copper if it has a volume of 41.8 centimeters cubed. So in this case, I'm just solving for density. So density equals mass over volume, and so then I just plug in. So my mass is 374.5 grams. My volume is 41.8 centimeters cubed, and so then I just divide. So once I divide that, I get 8.96 grams per centimeter cubed. Just like that. So these are a little bit easier than converting problems, right? However, I'm not going to lie, I can make you convert in a density problem. So just be aware it happens. All right, so hopefully you've already tried this one. It says a student needs 15 grams of ethanol, so there's my mass, for an experiment. If the density of ethanol is 0.789 grams per milliliter, so there's my density, how many milliliters of ethanol are needed? That means I'm looking for volume. Liters, milliliters, things like that are volume. All right, so again, I'm going to have to rearrange my formula. But I don't want to solve for volume in the denominator, so the first thing I want to do is get it in the numerator by moving it to the other side. So volume times density equals mass, but since I'm solving for volume, I still want it to be alone. So I will divide density to the other side. So like I said, y'all, I'm not going to spend time showing you how to rearrange a formula in this lesson video. We got other things to talk about. All right, so then I just plug in. So my mass is 15 grams. My density is 0.789 grams per milliliter. So my grams cancel. I'm left with milliliters, and so then I just do 15 divided by my 0.789. And so for that, I got 19.01 milliliters. So hopefully you got that one right. All right, so next one. These seem to be pretty easy so far. What is the mass in grams? So I'm looking for mass. And y'all be careful when it tells you what it wants, because then if I gave you kilograms, you would need to convert. So just be careful whenever it specifies a unit. So what is the mass in grams of 25 milliliters, so there's my volume, of mercury, which has a density, There's my density of 13.6 grams per milliliter. So this time we're solving for mass. So we know density equals mass over volume. I'm solving for mass, so I'm going to get volume on the other side. So I multiply, so mass equals volume times density, and so then I just plug in. Nothing like plugging into a formula, that's pretty easy. So the volume is 25 milliliters, and my density is 13.6 grams per milliliter. So if you look, my milliliters cancel, I'm left with grams, which is what it wants, so I don't have to convert, and I just multiply my two numbers. So I got 340 grams. Okay, so hopefully you're getting those right, and hopefully you're finding these a little easier than, converting how many liters are in the ocean when I give you kilometers cubed. So let's move on. All right, so there's my answers. So section assessment. So see how much shorter this one was? What determines the density of an object? So since this is just a verbal answer, I'm just going to say it. So the density of an object is the ratio of the mass to the volume. The ratio of the mass to the volume. So number 2, how does density vary with temperature? Well, in general, density decreases as temperature increases. Remember, water is an exception to that. But in general, density decreases as temperature increases. Alright, so our next one, it is a math question, so you might want to pause the video and try it on your own first, just to, make sure you got it. It says a weather balloon is inflated to a volume of this, 2.2 times 10 to the 3 liters, with 37.4 grams of helium. So there's my mass. Then it says, what is the density? Okay, so I have my volume, I have my mass, I'm just looking for density, so I don't even need to rearrange the formula. I can just plug in. So my mass is 37.4 grams. My volume is 2.2 times 10 to the 3 liters. So I'm just going to divide my two numbers. So once I do that, I got 0.017 grams per liter, because grams and liters don't cancel. But notice it says, what is the density of helium in grams per liter? So thankfully we got the unit they wanted, so I don't need to convert anything and I'm done. So like for example, if it had said, what is the density in grams per milliliter, I would need to convert at that point. Alright, so number 4. It says a 68 gram bar of gold is cut into 3 equal pieces. How does the density of each piece compare to the density of the original gold bar? Well, remember, density is an intensive property, which means it doesn't matter how much you have. So all 3 pieces, because they're still gold, will have the same density. Okay, density does not change based on the amount of the substance you have. So they would all be the same. Alright, so maybe for number 5, pause it just to try it. I'll assume you've done that and we'll do it together. So it says a plastic ball with a volume of 19.7 centimeters cubed has a mass of 15.8 grams. Would this ball sink or float in a container of gasoline? Here's the density of gasoline. So we need to figure out the density, because if it's less dense, it will float in the gasoline. If it's more dense, it will sink. So let's calculate our density. So density is mass over volume. So then I just plug in. So my mass is 15.8 grams. My volume is 19.7 centimeters cubed. So once I divide that, I end up getting 0.802 grams per centimeter cubed. So since it is more dense than the gasoline, because the gasoline is only 0.6, it will sink. So if it had been a number less than 0.675, it would float. But because it's more, it will sink. Alright, so let's move on. My gosh, this video is going so much faster than the last couple of ones I made. Alright. So there's my answers, and so the last slide of chapter 3. Okay, so this is a math question, so you might want to pause it and try number 6. I'll assume you've done that. So it says, what is the volume in cubic centimeters? So notice they have asked for a specific unit, so let's make sure that's what our answer is in. of a sample of cough syrup that has a mass of 50 grams. So there's my mass. Then it says the density of the cough syrup is 0.950 grams per centimeter cubed. So there's my density. So we're solving for volume again, so let's rearrange that formula again. So remember, we don't want to solve for something in the denominator, so the first thing I do is move it to the other side, so now it's in the numerator. But now I need it to be alone so I can solve for it, so I move density to the other side. So volume equals mass over density, again. So then we just plug in. So my mass is 50 grams. My density is 0.95 grams per centimeter cubed. So my grams cancel. I'm left with centimeters cubed, which is perfect because that's what it asked me for. So I just divide my numbers. So for this one, I got 52.63 centimeters cubed. So like I said, I have the right unit, so I'm good to go. All right, so the last one, it says, what is the mass in kilograms of 14 liters of gasoline? Assume the density of gasoline is 0.68 grams per centimeter cubed. So if you're planning on trying this one on your own, just know you are going to need to do some converting. Because I've asked for mass in kilograms and I gave you liters, but yet your density is in grams per centimeter cubed. So just keep that in mind. All right, so I'm going to assume you might have tried this one on your own. You might have been like, oh gosh, converting, I'm just going to watch her do it. Either way, we're going to go ahead and do it. So it says, what's the mass in kilograms of 14 liters of gasoline? So I have a volume, and then it gives me the density right here. And so I'm looking for mass. So I know that volume, I'm reverting back to my old formula. Density equals mass over volume. So if I solve for mass, I know that I need to move volume to the other side. So mass is volume times density. My density is grams per centimeter cubed, but yet I was given volume in liters. So the first thing I'm going to do is change my liters to centimeters cubed so that I can use it in the formula, because the volumes have to match. Like whatever your volume is, it has to match the volume unit on density. Okay, so I need to change 14 liters to centimeters cubed. You see how the units cancel sometimes? A liter and a centimeter cubed can't cancel. So I'm going to start with my 14 liters. So first I'm going to go from liters to milliliters, because I remember that 1 milliliter equals 1 centimeter cubed. That's one of those other conversion factors you're supposed to remember from section 3.3. So I know I need to get from liters to milliliters. That's one prefix, so it takes me one step. So I follow my golden rule and put liter on bottom. I'm trying to get to milliliters, and then I follow my formula. One prefix unit, or 1 milliliter, is 10 to the x base unit, and in this case it's 10 to the negative 3 for milli. So I've gotten to milliliters, but I still need to get to centimeters cubed, and so I can use this to get there. See, we just made density a little bit harder, huh? I love converting, so y'all sorry. Okay, so I follow my golden rule. I have milliliters on top, so I want milliliters on bottom. How many? I want 1 milliliter, and that equals 1 centimeter cubed. So my milliliters cancel, and then because I have one number on top and one on bottom, I'm just going to divide. When I divide that, I get 14,000 centimeters. So now that I have, centimeters cubed. So now that I have centimeters cubed, I can plug into my formula. So mass equals volume, which now I'm going to use this right here, 14,000 centimeters cubed, times my density, which is 0.680 grams per centimeter cubed. So if you look, now my centimeters cubed can cancel. That's the whole reason I couldn't leave this as liters. And I'm left with grams. So I multiply my two numbers, and once I do that, I get 9,520 grams. And so I know you're probably like, whew, we're done. However, not so fast. It asks for mass in kilograms. So that's why I tell you, you got to be careful. When they ask for it in a specific unit, make sure that's what you get. We have grams, so I need to convert it. I know, y'all are so disappointed, and I'm so excited. All right, so we got to go from grams to kilograms. That's one prefix, so we can do it in one step. That's not a big deal. So my golden rule says if I have grams on top, I'm going to put grams on bottom. I'm trying to get to kilograms. So then I follow my formula. One prefix unit, so 1 kilogram, because that has the prefix, is 10 to the x base unit. If you look at your prefix sheet, kilo is 10 to the 3. So my grams cancel. I've made it to kilograms, so I'm almost done. So I do 9,520 divided by 10 to the 3, since 10 to the 3 is on the bottom, and I get 9.52 kilograms. Okay, so there's two important things from this video. The first important thing is density is pretty easy. The second important thing is, though, whenever we do math for the rest of the year, just know converting can come back into play. Okay, so just always know that for the rest of the year, no matter what we do, if it's math related, converting can happen again. So you have to learn how to convert. The quicker you'll accept it and learn it, the easier the rest of the class will be. So sorry if you hate converting, but I love it, and so it's going to pop up a lot throughout the rest of the year.